Hello students, welcome to my channel Science No Problem. My name is Tish Kumar Sharma and I am teaching you science. So students, like our previous videos, this video is also going to be very informative and very interesting. So please watch the video till end and please like, share and subscribe our channel to support and motivate me. So before we start our today's video, let's take a quick recapitulation of the work which we have done in our previous video. So my dear students, we had done in our previous video displacement reactions. So I had told you about displacement reactions. Let me tell you again. Displacement reactions are those in which more element displaces a less reactive element and takes its position. So we had also done some examples. Now my dear students, I would like to tell you again that actually without knowing the reactivity series you can't actually understand displacement reactions. So to remember reactivity series, I had also told you the way also sentence actually I had told you how to remember this reactivity series. So please practice to learn reactivity series, and then only you can actually understand or you do reactions, displacement reactions. So my dear students, please remember the reactivity series. Now I would like to give you I would like to give you some questions based on displacement reactions to reinforce your knowledge. So question number 1 is state which of the following reactions will take place and which will not take place. My dear students, I hope that you have notebook and pen with you. So please note down these questions. Once again, state which of the following reactions will take place and which will not take place. Reaction number 1 is zinc in solid form plus copper sulfate aqueous. Aqueous means that solution of copper sulfate in water. So that is aqueous. When mixture solid is dissolved in water, when water is solvent, then that solution is called aqueous solution. So zinc sulfate aqueous plus copper. Second is iron plus zinc sulfate is equal to iron sulfate plus zinc. Third is zinc plus iron sulfate is equal to zinc sulfate plus iron. So this is question number 1. You will do this question yourself. Question number 2 is write your observation when iron nail is dipped into copper sulfate solution. Once again I am repeating, write your observation when iron nail is dipped into copper sulfate solution. So my dear students, I have given you these 2 questions, and if you have attentively attended our previous classes, then there is guarantee that you will be able to answer these questions. And if you are not able, then please watch those videos once again and then come on these questions. So please do these questions. These questions are very important. So my dear students, continuing our topic types of chemical reactions. Now we have actually double displacement. Today our topic is double displacement reactions. So double displacement reactions are also called precipitation reactions, because in double displacement reactions one of the products is of precipitates. Precipitates are formed, so we call them as precipitation reactions also. So this is I think number 4. Number 4. Number 1 was combination reactions. Number 2 was decomposition reactions, number 3 was displacement reactions, and number 4 is double displacement reactions. Double displacement reactions, or are also called precipitation reactions. Precipitation reactions. So, my dear students, let me tell you what are actually, before I tell you double displacement reactions, let me make you clear what are precipitates. I have already discussed precipitates. For example, in a solution, solid parts, solution is made up of solid dissolved in water, so that is, or in other solvent. So when the solid part gets separated from liquid part, then the solid part actually is of precipitates. For example, when we make cheese, so we sour the milk first, or sometimes what happens, okay, when to make actually cheese, what we do, we sour the milk. So then what happens, when we sour the milk, so what happens, that the solid part gets separated from liquid part, and that solid part is actually our cheese. So cheese is actually example of precipitates. Similarly, sometimes we get actually when we make curd of milk, then in curd we have liquid and solid parts actually separated. Now the solid part is actually our precipitates. So the precipitates we can understand through these examples, that what are precipitates. Now students, so these are precipitates. Now let me tell you what are double displacement reactions. So in double displacement reactions, actually there is the reactions in which there is exchange of ions. There is exchange of ions are called double displacement reactions. Once again, the chemical reactions in which there is exchange of ions, positive ions, so those reactions are called double displacement reactions. So now in double displacement reactions, since the one of the two products is of precipitates, that is obtained in the form of precipitates, so these are also called, sometimes called, precipitation reactions. So let me write the definition. Those reactions in which exchange of ions you can say positive ions takes place are known as double displacement reactions. Double displacement reactions. Or sometimes these reactions are also called precipitation reactions. So let's understand double displacement reactions through some examples. Now when we talk about ions, so it means that the chemicals which we will take in these reactions will be ionic compounds. Obviously, when exchange of ions will take place, it means that the chemicals which we will take in this reaction, they will be ionic. So ionic compounds are made up of metals and non-metals, I have already told you. And apart from these we have also there are also some compounds, covalent compounds, which are ionic. For example, uh, acids. Acids are actually covalent compounds, but they are also ionic also. So we will take uh, reaction between ionic compounds, and we can also take ionic reaction between ionic and compound and acids. So through examples this will be clear. For example, silver nitrate, aqueous plus sodium chloride, aqueous. Now what happens, that this is salt, this is ionic compound dissolved in water, sodium chloride, which is our common salt which we use at our homes, this is also dissolved in water, aqueous. So these are actually ionic compounds, and ionic compounds, I have told you, made up of metal and non-metals. So silver is metal, and metals give positive electrons, that is the definition of metals, and non-metals are those which take up electrons. So positive ion, positive charge, negative charge, positive charge on metal, negative charge on non-metals. So positive, negative. Now in this reaction what will happen? Exchange of ions. It means that silver will go at the position of sodium, and sodium will take the position of silver. Silver will take the position of sodium, and sodium will take the position of silver. Exchange of positive ions. So what we will get is sodium nitrate plus silver chloride. Now here, my dear students, now how we can identify that which are products, which are precipitates. This is precipitates, or this product is precipitates. So solid, the product with which solid is written, so that are actually precipitates. Once again, the product with which solid is written, so that are precipitates. So here we will get precipitates of silver chloride. Let's take another example. Barium chloride plus copper sulfate, aqueous. Metal, positive charged, non-metal, negative, positive charge, negative charge. So again there will be exchange of ions. There is simply exchange of ions. You should not be confused. For example, in our displacement reactions, more reactive element will displace less reactive element. So that concept will not be is not valid here. You will not think in terms of that here. There is no displacement here. There is no question of element being more reactive or less reactive. Here there is exchange of positive ions. So barium will take the position of copper, and copper will take the position of barium. So as a result we will get copper chloride plus barium sulfate. So these are actually precipitates. You know very well that from solid, the product with which solid is written, that are actually precipitates. So let me clear you once again that there is exchange of ions in these reactions, double displacement reactions, and the concept of actually using reactivity series, that is not applicable here, my dear students. Keep this in mind, that you have to see which metal is more reactive, which is less reactive. So that is not actually done here. So here we simply exchange. Exchange means what is mine will go to you, and what you have, that will come to me. That is the meaning of exchange. Let's take another example. Sodium hydroxide. Okay. Barium chloride plus H2SO4. Now, my dear students, this is ionic compound. Why this is ionic? I have told you, ionic compounds are made up of metals and non-metal. Barium is metal, chlorine non-metal. But here, if you see this is also ionic actually. But there is no metal element present in this acid, sulfuric acid. This is made up of only non-metals. It means that, what is the definition of covalent compounds? Covalent compounds are those compounds which are made up of only non-metals. And what is the definition of ionic compounds? Ionic compounds are those which are made up of metals and non-metals. So here actually we have, this is covalent compound, and covalent compounds are generally non-ionic. But acids, whether it is sulfuric acid, it is hydrochloric acid, it is nitric acid. So all are actually covalent compounds. Why? Because they are made up of only non-metals. But acids are actually, they are ionic in nature. Actually they are covalent compounds, but they also ionize because they are ionic in nature. So we have some covalent compounds which are also ionic in nature. Generally covalent compounds are non-ionic, but we have some covalent compounds which are also ionic in nature. So this is barium, positively charged, negative, positive, negative. Actually hydrogen also behaves like metals. So this is the reason that hydrogen in periodic table is given place among metals, because the properties of hydrogen is like giving electron and like metals. So that's why this will have positive charge and the sulfate negative charge. So again there will be exchange of ions. Again there is no concept of displacement, that more reactive metal will displace less reactive metal. That is not the case here. Simply you exchange the position of positively charged ions. So what we will get? We will get HCl plus barium sulfate. You can understand that which product is precipitates. So barium sulfate is precipitates. Let's take one more example. Sodium hydroxide plus HCl. Positive, negative, positive, negative. Exchange of position, positively charged ion. So it will, H will come here to make water plus sodium chloride. Now my dear students, here in this reaction you will not get precipitates. Water is liquid and sodium chloride, because sodium chloride is soluble in water, sodium chloride plus water, so we will not get precipitates in this case. So the salt which is dissolved, soluble in water, because water is there, product is water, water is product, water plus sodium chloride, so precipitates will not be formed because sodium chloride is soluble in water. So here precipitates will not be formed. So my dear students, I think that the topic which I have taught you today is clear to you. Still, if you have any doubt, then you can write in comment box. So this is all for today. Thank you very much for watching this video, and keep watching my channel, keep learning, keep growing. Thank you very much. Take care of you.